Hi, everybody. I'm excited to be kicking off and feeling very popular with all these chairs and people coming into the room. For those who don't know me, I just want to wave and say my name is Kristen Merritt. I work for the ALSYS Group, and I am delighted to be here today representing the ALSYS Flight team, who focuses on long-term sustainable development and supercomputing. There are three focuses, which is one of the reasons why I love coming to HPC Days, is that we're very big into open source and shared methodology, as well as advocacy for our clients in terms of best practices. So anybody, am I blocking the slide? By the way, I volunteer a lot with Melissa, and so I just take direction to whatever's done. Better?
Much better.
Okay.
There you go.
Melissa's happiness is all I'm here for today, everybody.
Thank you, dear.
And also the education and workforce development. I can stand up here and talk thanks to my sister companies who work in the commercial space for HPC, looking after said HPC centers, which is ALSYS Software and Concerta. So that's me. That's who I work for. Why on earth am I here? That would be a good one to answer. Well, I was lucky enough to keynote last year at HPC Days, and when this came around again and I could submit an abstract, I was thinking about less about now and more about the future. Because if you think about what's going on now, and this is the argument and position that I'm going to place in front of you, is that I firmly believe we are in this really exciting but very daunting period of transition within our field, where we are moving beyond what is really our core base of high performance computing, which is hardware performance. You heard a brilliant keynote this morning, those who attended today, from John, really talking about what we can do with hardware performance. But I actually think we're experiencing an interesting period of abstraction. And when you have something new come along and you have a lot of change coming on, it can be really daunting, very scary. And sometimes you can be frozen into just indecision in what you can and cannot do, especially when the rules we have in play are no longer really applying in the same ways that you say. So I can't believe you guys are talking about Fortran. I want to mentally ask and invite you all to place yourself 200 years in the future. And we're not here at HPC Days. We are actually here at the RSAF, that is the Royal Society for Ancient Fortran, Iatam Hic Est. It is still here. Established in 2126, it is actually the year 2226, and you are not system administrators, you are not engineers today. Today, I ask that you all consider yourselves historians. You are looking in on the past, this wonderful decade, from 2016 to 2026, in which we were working on this supercomputing civilization at the time. We refer to this as the period of the abstraction wave, and those who understand really terrible Spaceballs jokes understand that we are dealing in a society which is pretty ridiculous in terms of its computing. That is, of course, our light speed, ridiculous, ludicrous, and as we all know, we hope to one day ascend to plaid, which is set for 3026. But this particular period, these people of 2016 to 2026, where were their focuses? What did they value? Well, looking back at our civilization, we had a very high value on the physical assets. That was something that really drove a core foundation of the field. In terms of foundational research efforts, math, physics, chemistry, the things that actually drove us forward still had a big, huge underlay. But we had a lot of things coming at us in terms of change. So what we had was opportunity, introspection, and then we had a wave. Not as exciting as the tsunamis that we just witnessed, but a wave. In this period, people began to see a supercomputer as more than just technology. What I asked for that is that they are also looking at the composition of the policies, workflows, capabilities, and features, Fortran, Iatam Hic Est, it is still here, that has followed us historically through time to this day. The defining feature of the abstraction wave was a fundamental change in how our society aligned to the use of hardware. I'm not saying tossed the hardware or even tossed the hardware performance. It's the alignment which we are seeing change. So how, Kristen? So pre-2016, the biggest friction of any type of technical onboarding was users, right? You have any kind of new technology, your biggest friction is to get people to freaking use the system, right? Get them onboarded and get them going. Once they do that, they hit into what a leveraging period it is. You want to fill up your machine. You want maximum use of whatever technical revolution that you're putting forward. But eventually you hit this change point, right? New things are coming. What do? Pre-2016, the usual, I'm not saying always, but probably the majority response was constraint. I am feeling constrained. Why am I constrained? Performance. You always heard of like there's a performance decline. Most likely result pre-2016, I need new hardware. Give me something new because my performance is declining. The abstraction wave of 2016 to 2026, instead of change, something different happened. People wanted to not change because of performance decline. They wanted to adapt. Why? Reliable systems. Less about the fastest, most performance, most about the consistent, reliable nature. I feel so popular right now. You come with your own chair.
I'm so sorry.
Your room in the middle, it's just nobody's back here.
There you go. It's just quick readjustment so that, like, you know, the shuffling.
There we go.
So the short of it is, here we are, abstraction wave. And we're in this wonderful period of 2016 to 2026 that people are less about performance and more about the reliability. I'm not saying no one replaced hardware. I'm just saying hardware became one of many choices. There was a lot more about the optimization on portability, optimization on capability, and continuity. Why? Why move to adaption? What changed, Kristen? What was so crazy that people would kind of wander away? I'm not saying completely, but why would they want to move towards reliable system and not necessarily performance? Well, elephant in the room, 2016 was when all the big public cloud vendors came onto the scene in a big wave and said, you will replace all your hardware with magical cloud, right? Yes and no. Obviously, we learned along the way. But when you have large-scale vendors who have a much, much higher reach in terms of an audience than our particular niche supercomputing, you end up with what's known as a non-native user influx. These are not, well, let's all be honest. How many people in here knew from the start they were going to be in supercomputing and how many had them foisted upon them? But still, the truth is you're bringing in people from places you would never really expect. Digital humanities, one of the big rises here out of Durham itself. And then there's this thing, people might have heard of it, called AI. New requirements came flooding onto the scene because you have non-native users influx, people knowing they don't have to buy a supercomputer to do stuff. And this is what I call the internal discussions that we could have right here, right now, in this room, both as historians 200 years in the future and today about impacts on how systems were built and used. Then you have these external pressures. Money. You've got a lot of people coming in who want to use things in ways you don't expect, and all of a sudden the demand drives up, and the hardware and the space, physical capacity, become a really big factor from the outside. And when I speak of physical capacity, I'm also speaking about power, cooling, and environmental. And then you can put the bow on this, which is security. You got a whole bunch of new people coming in with stuff you've never seen before. The security, policy, and ethics have got to shift. Pre-2016, and actually still into the abstraction wave. What are the things that changed at the more actual machine level, right? Well, the hardware and performance is the base. In fact, it always will remain the base, and until we can abstract beyond hardware, it shall. You put your applications and your users on top. You tied them all together with an orchestration for efficiency and fairness. Get them on, get them through, get them off, hopefully as equitably as possible in order to keep your machine running at top efficiency. The abstraction wave did something different. Hardware and performance stayed the base, orchestration changed. Orchestration shifted from efficiency and fairness to trust and interaction. People wanted to stop and start and play and do different things at different times. So instead, you build an abstraction of software, governance, users, put them in a little box. On we go. What happens then? Performance of your service starts mattering just as much as the performance of your hardware. You have to not only have, and it's interesting because when John spoke about in his thing about this interplay, this bridge and connection, when you go into an abstraction state, you're right. But it's not just hardware anymore. It's very much how reliable is that service? How quick am I able to get on? How fast can I use it? And I'll give you two key examples of where the abstraction is making the fastest impact, right? Well, I drew a box. So of course, I'm going to talk about containers. And obviously, containers really kind of came into age with the start of the wave, with public cloud, right? And it was very much about adapting and negotiating inside the boundaries of the current hardware that has been presented to you. There are pros to this. Portability and continuity focused. When you have a non-native user influx and a lot of people wanting to use the system, chances are they're coming in and they want to kind of move around and collaborate from in and outside, right? So you wanted to have something that doesn't depend on the environment being consistent, consistency. You don't want to necessarily worry too much about the integrity, but we'll get into that. There's a trade-off there. And it simplifies that level of collaboration. Now, I'm not saying everybody go out and run containers because it's not always right for you. The thing that our field did that was so amazing for this was that, remember how I said hardware performance, that's our specialty, right? What do? Runtime injection. So don't build for everything to work, don't build your container to work on each bit of platform that you work on. We'll bring you the libraries, we'll bring you the configurations, as well as this host MPI GPU pass-through. So basically harnessing the performance of the system that you're running the container on. Wow, we're popular. And also, I know. And also, and also this great thing called schedule integrations, because containers are not technically those to our schedulers. So guess what? That's something that our field figured out. To make it more difficult, because we're an HPC, we like it more difficult, right? There's trade-offs. There is always going to be a performance cost. Now, the cost could be negligible or it could be major, depending. That's why I say containers may not be right for you, especially if you're a long-established system with long-established workloads, which you can tightly couple to the system to get that optimum performance out. Utilization efficiency peaks and troughs. And this was interesting when it was explained to me, was that it's less predictable what you can schedule to run on a system when the containers are involved. So people can come in and come out. And when you are running really expensive kit, you want it as full as possible all the time. Also, outsiders, supply chain, where'd that container come from? Very big trade-off to consider. And also, and finally, if you think about it, when I showed you that first slide and I said everything was stacked on top, that means everything's managed in one place, right? Containers actually move lifecycle management into the containers themselves. So you do have to think about how you manage those as they come in and out, including whether or not you live in a practice. Trusted research environments. This was kind of a late stage wave implementation. They've been around for a long, long time. We have these machines. It's holding a lot of very sensitive data. We'd like to collaborate on that data. We need to know absolutely everything. Easiest example is obviously healthcare, right? You want to be trustworthy at scale. I'm going to start with the bad stuff first, because I think The TREs, as exciting as they are, they mess with our culture a lot. How? It goes against open research. We're used to people being able to get on, and we're also used to them being kind of flexible, you know, the whole point of being able to be scalable. You actually have to prioritize accountability over that instead. And non-technical, but also technical, you got to coordinate governance. Because if you are running these projects and you have all these data sets and you're bringing your users in, people have to understand what the rules are, correct? And that leads to a lot of these TREs, and probably the reason why they're a late stage wave implementation, looking at it from a historical perspective, is because if done incorrectly, your cost and your budget and your timescale can go out the window very, very fast. Most of the papers that I've read about this is actually the users complaining that it took forever to get on the system. And by that point, their grant was gone. And that's the kind of stuff that we're dealing with here. There are pros, though. It addresses the sensitive research, and you can work under specific governance rules, process-driven, auditable, and accountable. A very big feature of all this non-native user influx is being able to track and understand what this system is using and why. And guess what? We already have that in place. It's one of the things that we could inject directly into TRE because we know how to do operationalization through infrastructure. We already do scheduling. We already know allocation and access. Basically, you're taking it to a much more secure level. You notice at this point in time, I've never said that the point of the abstraction wave was to get away from the past. It was never to get away from the hardware or the performance of it. It was only to begin to harness, leverage, and in some cases exploit within the design boundaries. This means people were no longer thinking about straight replacement or thinking straight about hardware performance. They were beginning to think about the service as a whole. Then what happened after the abstraction wave? And this is where you come in and where I've realized I haven't pulled out my cards. I believe firmly that as the abstraction wave kind of disperses, we are entering an age of accessibility. I think it started in the abstraction wave, and I think we're headed towards there now. And we have an incredible opportunity, and that's the QR code, and I do have some cards about this. For those who know what Elsa's Flight does, normally we have this event called Sustainable Reality, where we have everybody come to us, usually at some location in and around the UK. This time we want to come to you. And what we would like specifically is for students. There is a big, big drive for people to get into this space, not necessarily from places you expect. We held a breakfast on Monday thinking like a couple of people would show up. We had 12 students. What is it? Of the 12, 2 had some experience. The rest were just, I want to be here. That said to us, there is clearly a drive. And what we're looking for is basically a space, some power. We bring everything with us. And the idea is to get students hands-on into this kit to hopefully help make sure that this abstraction wave and all the pressures around it are managed appropriately and we get some new ideas in. So there's my summary for those of you who love reading small text, because that's what we're all about here. Short of it is, we're very much centered around hardware performance. I don't think that's necessarily going away. The abstraction wave is bringing in a need to look at holistic service. I gave you 2 examples. And I firmly believe we're moving from that into an era where we do have a lot more non-native users, and we do have a lot more people who are wanting to use our systems in very many. That's my talk. That's me. With my hair better. So thanks and questions.